talking about the AI gold rush. But while tech giants are fighting over the software, one company is quietly selling the pickaxes and shovels, making them nearly $5 trillion in value. Nvidia didn't just stumble into a monopoly. They spent decades preparing for a shift Jensen Huang calls the largest industry reset in 60 years. How did a company famous for making video game graphics cards become the undisputed engine of global artificial intelligence? Let's decode it. To understand how a microchip company climbed to a $5 trillion valuation, we have to wind the clock back to 1993. Picture this: a greasy spoon Denny's restaurant in San Jose, California. Three engineers, Jensen Huang, Chris Malachowski, and Curtis Preem, are sitting in a booth. They aren't planning an AI revolution. They are drinking coffee and talking about video games. At the time, personal computers were starting to render basic 2D graphics, but the trio realized that if 3D gaming was ever going to be a reality, computers needed specialized hardware to offload the math from the main CPU. They pooled $40,000 in savings, incorporated a company called Nvidia, and made a massive bet-the-company gamble on accelerated 3D computing. Their first product, the NV1, was an absolute disaster. It launched in 1995 using a weird geometric design that game developers refused to support. Nvidia was running out of money fast, down to their last few months of payroll. Jensen Huang had to make a painful call: lay off half the staff, scrap the entire architecture, and start from scratch on a new chip, or go bankrupt. They chose to rebuild. 4 years later, in 1999, they released the GeForce 256. It wasn't just a graphics card. Nvidia coined a brand new term for it: the GPU, or Graphics Processing Unit. It was a massive hit, saving the company from ruin and securing them a lucrative contract to build the hardware for Microsoft's original Xbox. They had conquered the gaming market, but Jensen Huang saw a looming trap. The gaming industry was cyclical, and chips were treated as cheap, disposable commodities. To build a lasting empire, Nvidia had to expand beyond rendering polygons. By 2006, Nvidia dominated gaming graphics, but Jensen Huang made a move that Wall Street initially thought was crazy. He decided to spend hundreds of millions of dollars, a massive chunk of the company's profits at the time, to force every single GPU they manufactured to include a new proprietary architecture called CUDA. CUDA stood for Compute Unified Device Architecture. Before this, GPUs were strictly locked to graphics. CUDA allowed software developers to actually reprogram the chip to do general-purpose, massively parallel mathematical calculations. Wall Street hated it. Analysts downgraded Nvidia's stock because dedicating silicon real estate to this unproven feature squeezed their profit margins. For years, investors thought Nvidia was wasting money on a feature nobody asked for. But Huang was playing a completely different game. He realized that a GPU's ability to process thousands of calculations simultaneously was perfect for complex scientific simulations, cryptography, and eventually machine learning. By putting CUDA hardware into millions of consumer graphics cards, Nvidia seeded an entire generation of computer science students, researchers, and developers. They learned to code on CUDA. It became an industry standard. When the modern AI boom exploded a decade later, researchers didn't use generic chips. They couldn't. All their software libraries were hard-coded to run on CUDA. By sacrificing short-term profits for long-term software lock-in, Nvidia built an unbreakable moat. Fast forward to the launch of the generative AI boom, and Nvidia found itself standing on top of a goldmine. When OpenAI released ChatGPT to the public, every major tech company on Earth instantly realized they needed massive computing power to train their own large language models, or they would risk becoming obsolete overnight. To build an artificial intelligence model, you don't use regular computer processors. You need clusters of thousands of enterprise-grade GPUs working together in perfect synchronization. And because of the CUDA software lock-in we talked about earlier, tech giants like Microsoft, Meta, Google, and Amazon had only one viable option: Nvidia's flagship H100 chip. Priced at tens of thousands of dollars per unit, With companies buying them by the tens of thousands, the H100 became the most sought-after piece of silicon on the planet. Demand completely outstripped supply, turning Nvidia's data center division into a financial juggernaut. But Nvidia's true genius wasn't just selling individual chips. They evolved from a hardware component manufacturer into a full-stack systems provider. They started selling entire server racks like the DGX SuperPod, packing thousands of GPUs tightly together with their proprietary NVLink interconnect cables. This allowed them to capture even higher profit margins. Rivals tried to build competing chips, but they continuously hit a brick wall. Software optimization is just as important as raw hardware speed, and because the entire AI ecosystem, from PyTorch to deep learning libraries, was built on top of CUDA, switching to a competitor's chip would mean throwing away years of software development. Nvidia had successfully created a silicon moat so wide that even the trillion-dollar tech giants had no choice but to pay the toll. Having the best hardware on the market is only half the battle. The real stroke of genius that keeps Nvidia's revenue compounding is their evolution from selling individual components to constructing entire end-to-end AI factories and moving into physical AI. Tech giants like Microsoft or Google don't just buy boxes of GPUs and figure it out themselves. They buy fully integrated rack-scale systems like the massive Blackwell architecture superchips and the GB200N VL72 systems. These setups pack tens of thousands of interconnected GPUs running complex liquid-cooled systems that function as one giant unified computer. By selling entire hyperscale clusters, Nvidia dramatically increases their average contract value from millions to billions of dollars per client. But it doesn't stop at data centers. Jensen Huang realized the next phase of computing is physical AI, teaching artificial intelligence to understand and interact with the real world through robotics and autonomous systems. Enter Nvidia Omniverse in their simulation platforms. Before a robotics company or an autonomous vehicle fleet deploys their AI in the real world, they train and validate it inside a photorealistic, physically accurate digital twin environment. Developers are using these engines to train humanoid robots and self-driving cars on synthetic data before they ever touch the physical floor. By tying their enterprise software, digital twin simulations, and high-performance networking directly to their hardware, Nvidia stopped selling a commodity. They started selling an entire operating system for the future of physical and digital infrastructure. Nvidia's ultimate trump card is how they are aggressively monetizing the AI layer above the hardware through a service they call Nvidia AI Enterprise. Think of this as the operating system for artificial intelligence, acting as a software Trojan horse that locks enterprise clients in for the long haul. Rather than relying solely on one-time hardware sales, Nvidia is pivoting toward a recurring software subscription model. They are packaging pre-trained AI models, frameworks, and infrastructure software into a neat paid layer that runs exclusively on their hardware. If a Fortune 500 company wants to deploy custom generative AI or industrial automation, they don't build it from scratch. They pay Nvidia an annual fee per GPU to use their optimized software stack. This means that even after a server is bought and paid for, Nvidia continues to clip a recurring software ticket year after year, fundamentally changing how a hardware company is valued on Wall Street. Nvidia didn't just get lucky with the AI boom. They spent decades taking massive, counterintuitive risks, first by saving video games, then by forcing developers to learn CUDA, and finally by building the infrastructure backbone of the modern internet. From a greasy spoon, Denny's booth in 1993 to a multi-trillion-dollar empire, Nvidia's journey proves that the biggest fortunes aren't made by chasing current trends, but by building the tools everyone else will desperately need tomorrow. Thanks for watching, and if you want to decode more tech giants and business empires, make sure to hit that subscribe button.